You can take over. You can start.
Okay. Yeah. So hi Z. So welcome to Data Production. So would you like to introduce yourself? Or wait, should we introduce ourselves first? Yeah, right. So hi everyone. So I'm Ashit Dharwal, and I'm a data scientist in finance industry since about 2.5 years now. And this is supposed to be a master class in test-driven development. And yeah, Mithul.
Hey guys, so I'm Mithul. Me and Ashit, we basically run the podcast and data science training here at Data Production. I'm a data scientist as well. I work for Decathlon Canada, and the plan for today is to teach you guys, what is test-driven development. So you've learned test-driven development probably on the software engineering side. But we are data scientists, so how can we do test-driven development on the data side, right? So that's the goal for today. So this is going to be a really open-ended sort of session, right? So people can interact with us. We'll go over some slides, but it's really a discussion, so we can interact, have a discussion, and see what is it that people want to know, and also how things are done in your own organization. So if your companies or if a team is involved in doing best practices or doing unit tests, these are the sort of things that we can discuss and go from there. And if people want to learn more about this, again, throw in questions. Let's have an open-ended discussion. You can unmute yourself, ask questions, and take advantage of this session as much as possible. Yeah. Okay, you can introduce yourself, Sage.
Hey,
yeah. I was gonna say, let me quickly talk about the speaker. So,
okay.
pleasure to have you. Yeah, pleasure to have you. Thanks for taking out time and doing this session for us. It really means a lot to us as well as to people, and giving back to the community, right? So yeah, thank you very much for doing this.
I'm glad to be part and be guest. It's wonderful that you host it. I think the major work is preparing the stage. I'm just hopping on and taking advantage of what you provide as a platform for the people who are joining in. And I'm also very happy that many of you are on the call, and it's going to be, I agree, going to be special, going to be something that in this regard, I guess you won't find so often. So I guess with a lot of gratitude, everyone can just follow along and get their questions out as well, interact, really encourage. To myself, I'm Siegfried Eckstedt, short just Ziggy or Zig. That's all how all my friends call me. So do so too. And I've been in the data and AI field for almost 8 years. And I started in the time when everyone was still talking about big data. That was when I like really entered university as well. And back then in informatics or computer science, everyone was about like, oh, we have so much data now, big data is a thing and we need to analyze it, data analytics. Wow, how do we do that? I found that thrilling and exciting at that time. I've still just done economics and finance as studies. So to me, in computer science and technology was always something that I used as a means to work on a problem that I had, and I was very pragmatic. Even before I started with university and my studies, when I've just completed my A levels, I was just with the help of a book on HTML and CSS, coded a website for the pharmacy where my mom was working, because the pharmacist asked me like, hey, we need a website. You young folks understand technology. Can you do something for me? And I've done that. So that was the first time I've created some software. And ever since I was like really that pragmatic. I came across a problem, challenge, and then the tools and the solutions, just used whatever was applicable. So I've done that big data and data analytics role as a consultant, so rather working conceptually, identifying use cases, identifying what's the value of using data analytics and how to go about your big data infrastructure decisions, and what provider to choose and whatnot. Was quite conceptual, so I wanted to get my hands on at some point. I wanted to really fulfill on all of the claims and promises that were around in the industry, and around the same time, there were these magazine articles stating that data science or a data scientist is the sexiest job of the 21st century. And I thought, wow, I want to be sexy. So then I went for that. And that's 5 years ago that I started working in data science. Again, really taking some boot camp on how to develop in R, how to develop in Python, SQL, and so on. And even before I could finish my boot camp, I already got my job. That was quite funny. And then I started working in the life science industry, I would say. It's like pharma industry, healthcare industry, working with the data there, really all kinds of data, pharmaceutical products, and like how much they're used in hospitals, pharmacies, and even some patient related data with diagnostics, and how in a therapeutical way products are being used. And that was a blast. That was fun. And still wanted to do something else or on top of it, and that was being self-employed or run my own business. And that I have started 3 years ago. And ever since I do a living as at first one-man show, freelance consultant, really with the skill set that I had at that time, doing data science, building data pipelines, doing some analytics on top, building BI dashboards, training ML models, having some lightweight user interface applications on top. And quickly I had more work than hands, and I asked some friends of mine who were also like freelancing to join me and help me out on some projects. And then we had a team, a little bit of a loosely coupled group at first, but it sustained over time. And we translated this into a company, like a private limited. And here we go. This registered company, like a true business, not just some solo entrepreneurship, freelancing, whatever gig. A true business is a little older than a year. And I'm doing this together with my wife, even. We're running the business together, and there are around 5 other people that are contributing. And this is it. This is what I do. And since I was working in the life science industry, or in an industry where software, data, machine learning models is being used in the interest of improving health, it's really important to have reliable tools. So you need to make sure that from a quality standpoint, you can assure that the data that you're shipping, the predictions that you're making are reliable. They are not shaky and are shaken up by a little bit of data input variation, and sometimes easier is better in terms of the model, but for sure performance has to be durable in that regard. And therefore having a look on data in a very cruciating way was always very important. And here I go. I'm a pragmatic guy. I solve problems as they appear. I've gone deeper and deeper into the question: why do you do this testing, and what are the options? How can we test, and how can we think about these tests also in a more strategic way, holistically, and potentially how can we automate these tests, and how can we also, as we are testing really a lot, potentially bake it into the practice of developing our data or machine learning tools, so that while we are developing them, we are already making sure that we have the required confidence in our tools that we usually get from the tests. And this is really it. I guess when we arrive at the end of this session, you will get to understand how to get to the point that you have the confidence that your software, so your data, your ML model, behaves in a way how you would want it to. So it shows the expected behavior. And you can rely on a comprehensive design of a strategy, test strategy. You know that your goals are fulfilled. You know that all of the test cases that you want to see are being fulfilled. And I guess since I have it on a couple of slides, we will have some slides that we show. I can also show you a little bit of hands-on how you can at least write a unit test and so on. So I guess there's plenty to offer. I'm a little bit nervous about time. Hopefully we can get to a couple of good points. But yeah, this is about it.
So I think for a lot of the audience, I think your last few sentences are like very important to understand. Like what exactly is a test? It is a way to ensure that your program is working the way you want it to. Right? I think that is the summary of it. Right.
Exactly. And I guess most importantly, it is confirming that the code is working. And now you would say, well, I do that all the time. When I write my code, then usually I have something in my mind as an outcome. And of course, I would check whether my code is compiling and whether with a given input, it processes this and results in the output that I want to see. Obvious, right? We do that all the time in a Jupyter notebook, whatever, quickly write it down, SQL statement in your data management system, whatever. And we do that. It's obvious. Even if you are working in an Excel sheet or whatever, you do that all the time. Though, if you write test cases as software, meaning to say you have code for your test cases, the beauty is that this can be retrieved. So the next time, the next day, the next week, whatever it may be, you write some other code and you extend your software package, then you want to make sure that the test that you have had the last week, the last day, whatever it may be, is also fulfilled. You confirm the code that you write today with the confirmation that you had some other day. And that is really, really cool. So I guess that's the true power that you can make use of, that a test that you do today, as you write your code today and you confirm it with the test that you write today, can be used with any new code changes that you will have in the future, and will make sure that all of your tests and all of your software is confirming on that level. And that is why we write tests most and for all.
And for people working in, in data, right? You guys probably know, about 80 to 85% of, code doesn't end up in production, right? And then these are the reasons why, right? Unit test is one big reason why, right? Because there's a breakage, right? So when you throw code, when you push everything into production without testing, obviously your software is going to break, right? And it's not going to do what you want it to do or what you expected of it, right? And this is why, now a lot of people in data domain are trying to, learn from software engineering how to do test, right? But it's slightly different, right? It's not as, you're not writing test as you would if you were a software engineer. Right? Now you gotta write test, but thinking about data, right? Thinking about data and the kind of data that you're gonna be inputting. Let's say if you're building a machine learning model, right? And whatever its output, whatever output you're expecting, right? So you have to think about test cases surrounding that, right? So that is something that people have to learn, and people are spending on learning about it, right? The creative part is thinking about what is it that I need to write, what is the test cases that I need to come up with, right?
All right, let me share my slides, and then we can also inform our discussion by that. And hold on, I'm just organizing my screen a little bit. All right, that worked out. We've just covered that point, that we want to write the tests in order to confirm that our software is showing the expected behavior. There is also something that you can go as next step, and that's called test-driven design. We will get to what that is supposed to mean. But as you can see here, I have a quote from Kent Beck, who's one of the guys who has formulated the ideas of test-driven development. And he says the reason why we do testing, let me say testing at first, is because we want to manage our fear during programming. So what does it mean? And he has said that in 2003, that's 20 years ago. So that means that the practice of software engineering has come up with these ideas 20 years ago. And slowly but surely, as Mitul just said, it spills over on the data and ML domain with the larger movements of ML ops and so on. And what Kent meant by the things we are so afraid of when we are writing software is probably that our code is not working. Like maybe today, maybe tomorrow, we change one component and then we break another. And really what we want to do is we want to increase our confidence in the quality of our code. So meaning to say, we want to predict the behavior of the software that we're writing? Is it a data pipeline? Is it a machine learning training pipeline? We just really want to be able to understand a black box better and potentially turn it into something that's called a white box, where we understand all of its behavior. And there is a process to it as well. So if you want to be test driven, then the idea is not about particular tools, or you need to use Python and you need to write it all in PyTest or so. None of that. It's actually a process. It's a practice. And this definition here I have borrowed from Wikipedia. And here they are very precise. They say it's a process. And test-driven in this regard means that you would write the test first before you actually go about writing the function or the other software that you wanted to write in the first place, the functionality. So first the test and then the code itself. And as you do that repeatedly, you grow the body of tests just in the same pace as you grow the body of your code in general. And that is a little bit vice versa and flipped around to how you would usually go about developing first and then have the test cases later. And now one would want to wonder, why do they do that? Now, there is something one has to understand, and it is the relationship that this approach has to many other agile ideas that come from the agile development, software development methods. And Kent Beck was one of those guys who were designing the Agile Manifesto. Now, such as you find it with many other agile practices, take continuous integration or so, the usual idea that we have in agile don't allow work to pile up and accumulate. If something is painful, then we rather do it iteratively and more often. But as we do it more often, such as continuous integration, you integrate your code every time you change something, or at every day, whatever. And the more you do it, the less painful it gets, because then you, like with code integration, you don't need to find where are the merge conflicts and so on. It's less painful. The same idea here applies with testing. If you just write your code and then you have a big body of legacy code, and then after some time of development, you look at that huge body of code and you scratch your head and you're wondering, like, oh my gosh, how am I supposed to come up with all the test cases here that are required, like, to make it like 100% test covered? Therefore, the idea is, let's not get into it in that way. Let's rather make testing a part of our iterative small development loops. And in order to make sure that we do write the tests, we will even be so bold to write the test case first and then start going about the writing of the actual functionality. Now, that will result in a process that's called red-green refactor. What does that mean? What is red and what is green? Red means a failing test, meaning to say you write the test first, your test case, and then you test it against no functionality at all. So therefore it's red, right? So if you have a test case and no functionality, this test case has to return an error. Therefore, it's red. Next stage, once you have done that, you write production code. So your functionality, but you only write as much as is required in order to turn your initial failing test into a successful test. And here you go, you have the green stage. And as the next, the refactor stage, you remove the code smells. Refactoring, probably you're familiar with this, is a process where you don't change the functionality of your code, but you improve the design. So maybe there are some hard-coded values, or you have not named it properly, and so on. And you just do that. And then you go about the next test case. And you should do that frequently in quick iterations, as quick as you can. And it should not take more than a couple of minutes to go through one of these loops. And then you get into a habit where you create tests as you develop your code. And you also, as you are always in this mindset of how can I prove that my code will, or my functionality is actually enduring time and all the requirements that it may come across, you will write code that is in its quality enhanced and will show a very good design, just because you at first really expose yourself to that question of how am I supposed to test it? And that is the idea how to practice it, because test-driven development is a practice. Now, my question back to my lovely hosts, how much of test-driven development have you done so far?
Mithul?
So for me, so this is something like we do very often, but this is how it started, right? But then the thing that you mentioned earlier, right? We write a chunk of code, and then we think about, how do we write test cases? Right? This is something that I was stuck on early on. So my company is very, very much following, best-driven practices, as well as, test-driven development. But initially, during the early days, right, when we started doing this whole thing, no one had really an idea about, how to go about doing unit tests, right? Or how to go about designing these test cases, right? And the usual thing that we used to do was, we write the entire, development ready code, and then we think about, okay, what other test cases can we write, right, based on the code that we just wrote, right? And yeah, this is where, like you mentioned, right, you miss out cases where there are chances that your code will fail in production, right? So just writing a small chunk of code and then thinking about test cases, it removes that bug which you might end up with in production. And that is something that I've learned recently, and also through your talk that I've attended before, and I started implementing it. So that's about it on my end. But yeah, no, this is a really good point that you mentioned, and I think it's a good point for beginners, right? People who are just getting started and thinking about how to do test-driven development in the data and ML domain. Yeah.
So I really haven't done any test development yet. So usually what we do at my company is we first write the development code, and then we think of tests, right? So, but yeah, I will probably start doing it. I think we will. Yeah.
Yeah. The other thing I want to touch upon is the refactor. Right? It's a really important point that you brought up, right? Refactoring your code. Again, this goes back to how early you are into your in your professional field, right? So if you're just getting started in the data versus someone who's already in the field for 4 or 5 years, they know the difference of refactoring, how important that is, right? Again, this is going back to me during the early days, right? We used to write code, but we used to use hard-coded values, right? And what happens with the hard-coded values is when you're writing the code, you're just thinking about one scenario, right? And this is where you put in the hard-coded values, right? But the thing that you're building, you have to think about it. You got to have a different mindset, right? Whatever project that you're working on, you got to think about it as a product or a software that's going to be lasting for a really long time in production, right? And this software, it's not a one-time build. You're going to build upon it over and over again, right? You're going to expand that software to have more functionalities, right? And this is where, that those hard-coded values are not going to be useful, because now, you got to refactor your code, you got to modularize your code so that it can do more than one thing, right? And that's where, again, the test cases will play an important role, because now you don't have hard-coded values, right? So you can test for different scenarios, not just one value, or your code is not relying on just a single value, right? So that's a really important point that you mentioned right there. Refactoring.
100%. That's so important to also change your thinking about your product here, really. It's not just a little bit of a prototype or a project that you spin up and then never mind, next week forgotten about it. You should really think about it in a way that even in 50 years, when you will end your career, there will be people still using this code and they will be so happy that it's still running. And it's such a wonderful design that it endured time. Even though I'm skeptical about like what this scenario could happen like this, because technology is just crazy these days. But this is how it should be. This is also I think the most successful software that I can think of. Usually in companies or so, people would be swearing about legacy systems, but I have seen legacy systems at some of my workplaces that have endured 20 years or so. What a crazy good software, I thought to myself, right? So we can reach that. And particularly if we think about it in the way how Mitul just mentioned, and also to answer the question that I set up, like how much do you use test-driven development as a data scientist? During my years as a data scientist, I've never used it. Like I've never written a single test case. Only once I wanted to learn more about software engineering and apply it to data and ML, and let's say do software engineering for data and ML and not data science. I learned more about software engineering, and there I came across like how to actually write good code, and this is where I got it. And then I started like talking to my data science colleagues and so like, guys, you have to listen to me. This is great. I will give you a tutorial. And so it started. And it's really a cool thing. Let's go a little bit deeper into it. I will skip a couple of slides because I think yeah, well, you can self-study them. I'm very sure your Mitul and Aishit will be very happy to circulate the slides if anyone asks. I want
Let's
to
take an example
Before you go
test.
on to, sorry, I was going to say, before you move on to your next part of your slides, we do have a question from someone, and I think it's a really important question that we should answer. I feel this is something that I was going to ask, but it's good that you asked, Harsh, because I forgot about it. So the question is, doesn't writing tests before development require experience of where the bugs might occur? How can someone new to the industry write test cases before the code? And that's a really good question. I was going to ask that, and I completely forgot about it. Right? This is something as a beginner. Yeah, this is something that one might come up with. How do you write about writing a test cases, because again, you don't know what kind of data you're working with, or you don't know the kind of code that you gotta write to analyze that data, right? So yeah.
That is a wonderful question, and I think this is something that we will always, beginner or not, face when we look at any legacy code. So any code that you yourself have written in the past or someone has written in the past, you open a new repository, it's a new project to you, and you have recently learned about testing, so you know this is also it's an important project, so you want to make sure that this is tested well. Where do you start? Like, how do we make sure that the test cases that are important are in there, or there are no test cases at all? So what test cases should we formulate? So the system has a couple of features. What features should we have a test case for? And if we do a test case, if we formulate a test case, how do we do that? Like, what about the test quality? How can we ensure that we have high quality test cases? These are points that all come into the larger consideration of writing a test strategy. So actually, it's quite good that this question comes up, because it's the next step, I would say. And it's for sure not a reason to feel discouragement or so. It is a sign that you take it seriously and you do, and you are on the right track. Because here you go, you think the way how you should think. What are really the most important aspects of my system that should be reflected and confirmed by the overall test suite? And I gonna continue on that, but I want to answer the question and respond to the curiosity that was expressed. If you don't know yourself, and also your software engineering or developing peers don't know, then most probably the subject matter experts that you are working with, who are not coding, they know. They will know what is the most crucial part about this process, this product, what really ensures that value will be provided to the end user, the customer, whatever it is. So you can reach out to the subject matter experts, to the product managers. Maybe sometimes it's even the project manager or so. Those who can really evaluate on what is important here. Is that sufficient? I will also go in more detail in the next slide. Yeah.
So I'll give a small example. So for Harsh, Harsh asked the question, right? So it is, so as you keep coding and developing projects, right, you get more and more experience, and you sort of start figuring out where a bug can occur. So for example, you're writing a function to read a CSV file, right? So, and you know the expected output, that it should return probably a data frame with at least a certain number of rows, probably, right? At least not zero number of rows. So that can be one test case, like what is your basically your function returning, or maybe even the read statement that shouldn't return an error, something like that.
Yeah, and the thing I was going to mention, Chase touched on, was any project that you do, right? Someone asked you to do it, right? So it's more on the client-facing side, right? So any project that you're working on, either the product manager or or someone from, let's say, if you're working in a retailer, the supply team or the marketing team, someone has asked you to work on that project, right? So these are the people that you should reach out to. These are the people who know more about, let's say the data that you're working on. These are the people who would be able to answer the scenarios where things are not working out for them, right? So based off that, then you can design and think about test cases. It's something that Sage touched on, right? Again, as a data scientist, you're always working, the kind of roles that, or the projects that you end up working on is always clients facing, right? Or either, you're working under, let's say, a senior data scientist, then that person would know more about the data. Then that's a point of contact, right? So you reach out to the senior data scientist, and you discuss about the project more into detail, and that will give you an idea of where things are going, and where things are failing, and what is it that you're trying to actually solve. Like, again, the business requirement, the business problem statement they're trying to solve. So from there on, you can think about the different scenarios where the test cases can come in handy, right? So that's one way of doing it.
100%. I second that. And when you start off with your test strategy, and this introduction I will use to finish this slide here, and then we can move into the more meaty parts. But in order to get your test strategy a little bit of a skeleton, what you should set up at the first place is a goal. And as Mitul has mentioned, if you're a beginner, there's someone who probably has the goal in mind. So ask them, what is the overall strategic ambition here? Do we have some security concerns? Do we need some specific performance? Do we have a lot of data or very frequent loading issues? Do we have some input validation, as Aishit mentioned, with the CSV input files? Do we need to make sure that the CSV files are tested against colon separators, semicolon separators, maybe some delimiters, maybe some encoding, whatever it may be? Working for German markets and German customers with different encodings, I can tell you this is always an issue. So should we test for that? We should, right? And this should all go into the considerations, at least as of forming the goal into your test strategy. But then people, when they hear tests, they will already have some things in mind, and you should be aware of this. So far, we've been really thinking of there are some features, and we want to create tests. But what are the features, or what are the let's say what is some opportunity for you to create the test case? There are 5 considerations that I have here, not a complete list for sure, but think of this: whenever you have a recent enhancement or a recent change, that can be a reason for you to write a test case. So you create a new piece of software, you also create a new test. That is obvious. But what if there is a large legacy code stack, and you need to at first go and have some test cases created? Then I suggest look at core functionality. So what is the real core of the product that you're looking at? Next, a risk assessment could be interesting. So if there is something that presents more risk, and what's also very significant to your customers, users, and so on, maybe it's some third-party code as well. Have that, put an eye on that, and have that formulated in a test case. Another thing, very popular, I love it for myself, really, to think of these problematic areas. So it's some functionality that frequently broke in the past, or where you already know, like, that's sketchy. then do a test for that and make sure that it doesn't produce any problems in the future. And another very good point is also specialized knowledge. So if you have a feature where you know there is only this one guy in the team or department or company that really has the expertise on that, then get a talk with that individual for half an hour or so and ask him sufficient questions to understand how to translate his knowledge into test cases. And then you don't have to ask him in the next couple of weeks and months whenever something was not correct in your software, because you have the test cases that make sure that you don't need to ask him. That is really interesting if you think of siloed organizations where people are hard to get hold of. And another thing that I want to make you aware of are the many, many types of tests. So unit tests is what we talked about so far. You can apply these unit tests to data, machine learning, and the UI. That's number one, what's causing complexity. But once you start talking about testing and types of tests, you will hear colleagues talking about end-to-end tests. And this is really the top test, while a unit test is on the whole other scale of the spectrum. A unit test just focuses on one individual component of your whole code stack. That can be a single function. And the end-to-end test is really the idea that from the beginning to the end, you have one test that basically makes sure that everything is running. And you can already imagine that this is a little bit complicated or complex. Therefore, you shouldn't do that too much. But I have a disclaimer here for you. These end-to-end tests, they sound very, very nice, and your managers would love to have them a lot. And this is not how you should design your test suite, though. This is where the test pyramid comes in. It's a concept that originates with Martin Fowler and ThoughtWorks a little bit. They popularized it, at least. The idea is that you should have, on the basis of your types of tests, the unit tests, and you should have a lot of them. And the basis should be wide, and you should have a lot of unit tests. You should have only very few end-to-end tests, if any. And in between, the tests that check on whether multiple components of your software, which are each tested by unit tests, whether these components combined work. These are integration tests. You have them in the middle layer, and there should be a healthy one, but not too thick. So in all, it forms a nice pyramidal structure with the end-to-end tests on the top and the unit tests on the bottom. Again, here on the slide, there are so many types of tests. Don't get terrified. You can read them up later on. But the idea how to navigate this is as follows. You should think about that bottom up and left to right. What does that mean? Bottom up means you should think of unit tests first. So write a lot of unit tests in order to confirm that the functionality on its root level is confirmed. And only then move to the integration tests or end-to-end tests. And left to right, if you consider the progress in the, let's say, development life cycle of your data and ML software, you would usually start with data, and then you would move on, and based on the data transformations or the processing pipeline that you've built, you would have your ML pipeline on top of it, and then it would be catered to a user interface. So you could think about it like left to right. And this is also how you can formulate your unit tests. As you are creating your project one step at a time, also create your unit tests one step at a time. So think about that in a left to right scale. I know this looks like a lot of tests, and therefore you have to, let's say, not get overwhelmed by that, and apply a little bit of structure to it and navigate it therefore with more ease, and not throw it overboard and say like, no, I don't want to do it anymore, it's too crazy. Focus on the simple stuff, bottom up, left to right, and that will get you far. There is one more thing that I want to highlight, and I think we can also comment a little bit on that. And it is how to make sure that, let's say, I write a unit test, I can ensure a high test quality. So how many test cases do I need after all, or how much do I need to do in order to get high quality unit tests? And what you can consider is thinking of what arguments you provide to the unit tests, or what type of unit test you write. It could be that your unit test reflects the happy path, everything normal, as expected, nothing outrageous. It just does what it's supposed to do. And you test that with a couple of test arguments. I will show the architecture of or the structure of a unit test in a little bit, and then you will understand how this can show up. It's suggested to have about 2 or 3 of these normal arguments that you test against. Next thing is special arguments, or any special cases that could come up. That means maybe boundary values. You want to have a range of values that are being processed, then check the first and the last value. Or there's some special logic in your function that it works in some case like this, and in some other case it works like that. And you should for sure have a test on that. I would suggest you at this point to include your team. Meaning to say, have a brainstorming session, or really ask your more experienced team members. And there you can generate more special cases and all possible scenarios, and they will know. So if you are more junior, that's all right. Then ask your peers who are experienced, and actually they are really excited to go about this. Like if it's a little bit of an intellectual exercise, and it's always fun. Next, the error arguments. That is kind of not the normal or happy path that we had so far. It's the bad path. So how can things possibly go wrong? And you should test against all of these possible error states. And you should have 1 or 2 for these test cases. And I guess this comes back to the question of, yeah, okay, like what type of tests should I write, and what quality do I need? And therefore, I guess it also gives you a little bit of a more better understanding of how to write the test cases. Is that what was in your mind as well, Mitul? I think when you mentioned that it can get a little bit overwhelming with knowing what test to write.
Yeah, exactly, right? Like the pyramid that you have presented today, like I didn't know about that before, right? And now I can think of, obviously it's complicated initially when you look at it. But yeah, as you work through it, like you mentioned, as you work through it, it gets easier, right? And now you can, it broadens your perspective on the kind of test cases that you can write and in what areas, right? Like up until now, all the test cases that I used to write about was mainly about checking the data quality, right? Something that goes into my model, I want to make sure that the data quality is good, right? Because my entire model depends on that, right? The output that I'm going to get completely depends on the data quality, right? So until now, that's the only scenario that I used to cover in my organization, thinking about data quality, writing test cases for that. But now, after looking at your slides and hearing your talk, I can look at other sectors, right? The other areas where I should really start thinking about test cases. Right? There's this ML part as well as, the part after that. Right? So having like a full coverage, comes in very handy, for sure.
I have a question, maybe I can pick it up. Do you think that it's required to have 100% test coverage?
Not really, I feel. Again, as to why, I still haven't figured out why. But I do feel having just about 70-80% coverage is good enough. Again, it mainly comes back to the question of, what are the scenarios that you want to cover, right? It comes back to that, right? What are the scenarios that you want to cover, and does that fall under, that 100% coverage, right? So things that you could think of, things that you want to cover, and if you have covered all of that, then for you that's 100% coverage. But in reality, that wouldn't be 100% coverage because there are things that you missed out and you haven't thought about, right? So yeah, I'm still in that spot where I'm still trying to figure out whether having 100% good coverage is that is that good or bad when it comes to production, right?
I want to
Mhm.
extend before maybe Ashit goes and answers the question. I want to extend and say, usually you have, like in a GitHub repository or GitLab or so, there are tools that can indicate to what extent this package has been covered with tests. And what it does is that it checks every function that is defined in the package. Is it reflected by a test case or a test function? Whatever it tests. So the test function could not test anything, but result in 100% test coverage. So do you need 100% test coverage then?
No.
I think it's a trade-off. So because let's say you get a project from business and you need to deliver it within a week, right? Now, if in this case, you would only cover those test cases which are absolutely critical, right? And if you start writing the test case for every and all functions, then you would actually take like 6 days writing tests and just 1 day writing the actual code, right? So, and also like depends on the how critical is the project, and what is the impact of the project if it fails, like if the code fails. So if millions of users get impacted, you probably want to test it very thoroughly and like probably like 90+% coverage. But yeah, if it is a small project which is used only internally, then I would even go with like 10% coverage.
Yeah, I think at this part, we may not confuse quantity with quality.
Yeah.
And what's important to understand, I think, is that, well, if you have one function in your production code, it can be reflected with a lot of different test cases. And then it would still only mean that it is 100% covered with a test, right? Because if you write 2 tests for one function, it's still 100% test coverage. It's not 200% test coverage. So therefore, we have to, and I think that is something in the industry that is controversially discussed. And some people say, I never write any tests. And some people say, I write tests more than anything else. So I think we have to get a little bit sane on what we need. So therefore, and I fully agree with both of you, we need to focus on what really matters, right? If we have something which requires high quality tests, and that means we check for the special logic in it, and we know that there is core functionality included, then let's focus on our testing on this. And yeah, that's great answers. I couldn't answer better. That's really cool. I wanted to show the unit test, and then I also have one more slide that would inform a little bit on specific tests on data, specific tests on ML and ML pipelines, that you can have a little bit more of, like, let's say, inspiration on how to go about your data tests, ML tests, and so on. And
before
this here,
next slide, sorry to interrupt you. Before you move on to next slide, I just want to throw in some tools that, you know, we talked about coverage, right? So I just want to mention some tools, and again, people, if you guys have know any tools or use any tools, I think will be really useful for others to know. So one of the tools that we started using, adapting recently is, before we used to use this library called Coverage. I'm not sure how many people know about that library, but there's a library called Python library called Coverage, where you can cover your 100% of your code, and you can write unit tests and all that stuff. But now there are third-party tools that you can link it to your GitHub, and any code that you write, you push it to your GitHub. Basically, the third-party tool would scan your entire code, right? And then it will tell you, the coverage. It will also tell you how good is your code. What I mean by how good is your code in terms of best practices, right? As if following best practices. Are there duplicates, right? So if you're doing something, if you're doing exact let's say process 4 times, it will tell you, like, hey, this is a repetitive process. So maybe, turn this into a function and then use that function instead of you doing it manually 4 different times. If you have hard-coded values, it will tell you, right? So there are tools like this, and also, like I mentioned about coverage, it will tell you how, whether it's 60% covered or 70% coverage, and so on and so forth, right? And if there are bugs, even it will tell you if there are bugs, right? So let's say the part of the code where you were supposed to use a whole number, but you have used a float, it will tell you why you shouldn't be using a float. What could happen if you use a code, if you use a float, right? And it will also give you an explanation. That's the best part. It will give you an explanation as to why not to use it. It will give you a little example, right? So these are the things that these days the third-party tools comes in handy, and they are really useful. Like, we started adapting this one tool called Sonar Cloud. Not sure if people heard about it before. So we linked our GitHub to Sonar Cloud, and now we're exploring it, right? And you spend 30 minutes of your time just exploring what Sonar Cloud is, the reports that it generates for your script, right? And then you go through it. It's like a checklist. You go through it, you try and resolve those checklists, right? And you can customize it as to how much coverage you want. If you want 60% coverage, you can customize it. So I would encourage people to go check out, and any project that you're working on, even if it's a project, personal project that you're working on just for your resume, utilize this, right? It will show the recruiters, the data science managers, that you're thinking about these things, more on the MLOps side, you're thinking about these things, and taking stuff from the software engineering side and bringing it to the data domain, right? So just wanted to throw that in.
Wonderful, yeah. It's really wonderful, and when you are in search of tools, you will quickly understand that there are way too many, and a lot of really good ones. And I have an example here that was written with yet another tool, but it's I would say probably the most popular one when it comes to writing tests with Python, and it's PyTest. I have used it because it's just really fairly popular, and I wanted to demonstrate how you can structure your code when you actually write a unit test. And this is almost in any case a three-step structure, and it is setting up the test data that you have for the context. Second is calling the function or method that you are confirming here, really the function at test. And as a last point, assert that the function, what it turned out, outputted, meets the expected behavior. So you usually define what expected behavior you want it to show, and then you assert it in an assert statement. This is something that with different frameworks, there is an arrange, act, assert framework. There is another framework which is called called given, when, then, and it's from the behavior driven development or design principles. They all follow the same idea. You first set up, or you say, given that something is like that, and you call, so when I do this action, then I want to see this expected behavior to show up. And with this structure in mind, you can just really go ahead and formulate all of your test cases, unit tests for sure. When you particularly write tests with PyTests, then you have to also know, but the get started page of the PyTest documentation will get you up to speed very swiftly. You will understand that all your tests have to be in a folder called tests. And then if you want to test a specific function, how I here test a difference in months function, then your either the test function or the test class has to have the test in starting in its name, and then you call the function in your test suite in the test file.
So any reason to use a class instead of a simple function?
Yeah, there is a particular reason. And it is that you can organize the tests better. Here I have a class for that function difference in months. And then all of the methods inside, the first one is called test normal behavior. These can reflect the different test cases. So I can have one for normal behavior. I can have another method for bad behavior, error as an output. And that allows me then also, like if you work in your IDE, you can collapse and so on way easier and work with it in a more structured way. So I have done both. I have also formulated my test cases not in classes, but only in functions. And I sticked actually with this. Was a recommendation that I picked up as well. And I found it neater, really better structured. That's why.
So you would have a separate class for every function, right?
Exactly, yeah.
Want to text. Okay.
All right. Any deviation from how you would write your tests from this, or what do you think? Have you used this 3-step structure?
Yes. Yeah.
Yeah, instead of class, so when I learned about so there are 2 standard libraries, right? So we have unit test and then PyTest, which is built upon unit test. And when I first learned about the tester and development, unit test was something that I learned about, right? So writing classes, basically when you're using unit test library, you mostly end up, correct me if I'm wrong, but you mostly end up writing classes, right? And then I switched to PyTest because people told me like PyTest is much better and very intuitive, easy to understand, and can do a lot more things. So now in my company we use actually PyTest, but I never really understood the difference between PyTest and unit test, other than unit test you write classes, but in PyTest you don't have to write classes. You're just writing functions. So yeah, so these days I usually just end up writing functions and then test these functions. That's how I go about with PyTest. Yeah, but this would be the approach that I usually follow, and yeah.
Yeah, works brilliantly fine. And I think the reason why I structure it that way is I can, like, in the methods inside the classes, I can really also make it a little more telling. The naming of the method inside the class can really be descriptive. So here I say test normal behavior, but I could also, if we go back to the example of reading in data from a CSV file, I could say test a German formatted CSV file. And then the test case, even the naming of it is really telling, and it's still under the class which is related to the original function that I want to test. And therefore, when I define the overall test suite, I don't have to come up with very long names in order to have the relationship done. No.
So now you can have the same name, that is test normal behavior, for all the different classes, right?
Yep. There was one thing that I also wanted to show, and then I think we can probably also call it a wrap. And I wanted to highlight the possible tests that you could think about. And this is, I think, like some hands-on examples that make it a little more easy to apply all of this than it is how to think about your tests when you test data at the first place. The easiest is to have some really deterministic tests, meaning to say, do your values follow in an expected range? Or even, do I have the explicit columns in my data set that I would expect? Do we miss some columns because it's data input and we need to validate first? All of this validation probably. Next, statistical tests. So not that the values are there, but what quality do these values have? Do they fall in an expected distribution, where, as I know that mean value should be in this range and it should not be skewed, at least not terribly. I should have about this and that standard distribution, and so on. Next point, what you can check as well, that's on top of it, I would say, feature importance. If you have some chosen values that provide value. You need to check, are they providing enough value or importance? That's already when you potentially are in the processing stage for building up a ML training pipeline. And another thing that could be of consideration for you is data privacy. Now, that is, of course, relevant for those who deal with private data and in industries that are heavily regulated, financial industry, for instance, or healthcare and so on, where you need to make sure that data is anonymized, let's say, and maybe also de-anonymized at the end. And with testing models, I think that is something that we would always do, sure. Though if we have that formulated in test cases, it would always be done whenever you train a model. So that's actually pretty cool. Holdout tests, you probably know all these. Have some base model comparison. It's very easy, can be set up very swiftly. Maybe you can also check against some model staleness or drift, or whether there's some bias in the model. For sure, this requires a little more build up in the test, but can be done. And lastly, you can think of something that is more going into the integration testing for your pipeline. So at first, you can check your pipeline in a very easy reproducibility approach, meaning to say you get the same model after training on the same data twice. So you train it once with that data, you train it twice with the same data, you get the same model. And another thing that you can check with pipeline integrations is really having the step-by-step computation of all the model of the pipeline, whether the model during the training really gets compiled and you get a simple example out of it. Question back to you guys. Which of these tests have you been playing with, and have you formulated any of these tests in a test suite? In a unit test?
For me, it's mostly the stuff from, again, that test the data. For the test the model part, yeah, I'm still encouraging my team and myself to start thinking about model drift and start using packages like Great Expectations, and I think there's a couple of other packages which are really useful for monitoring purposes, and then considering these test cases. But I do less of ML, so for me the first category is what I usually end up with. But it's good to see various places where one can think about test cases and the kind of test cases that one can think of, right? So I think the one other thing that we usually do is, because you're using many different tools, right? So you're doing integration of let's say AWS or GCP and so on. So we also end up writing sort of test cases for those, mainly reading data from somewhere and making sure that it's the right data that you're reading, let's say from S3, or pushing data to GCP, making sure that you're pushing it to the right BigQuery, the right folder, or the right project, right, and the right table on BigQuery. So those are the additional things that we write test cases for. Yeah.
So I usually do the training reproducibility test manually. I haven't written a test case for it yet. Holdout test I do manually as well. And I think three or so years ago, I worked in an internship where we were building a master data management tool. So there we did a lot of these data tests, like all the statistical tests and range tests, distribution tests. These things we did.
Yeah, I have a similar experience, and I've also done like the tests usually where I would have a need for it. Like things are changing quickly, or they are moving quickly, so I want to be able to respond to it quickly as well, like with having some tests there that I can like comfortably relate to, even you know, when I even if I don't do it manually, I know it's been done. And this is also something that I want to stress, and as like something that like some takeaways. I think many of these parts we have highlighted across the talk, and maybe this will be also good for us to wrap it up. I guess the entire slide deck is available with your hosts. Really reach out to them and request. I've prepared them with a little bit more text. It's good for self-study, therefore it's fine. But a couple of things I want to reiterate, mostly because we talked about it. This makes most sense if you need fast feedback and if you want to apply it to something that's changing quickly. So whenever you think about automation, or you have a need for confirming on something repeatedly, then it should ring a bell, and you can go to these concepts and create your test suite in a way that you can rely on it whenever something changes, because then you have the confidence that it will always be working as expected. Secondly, I think you should not forget that it's a practice, so you need to get into it. At first, it is awkward, one has to admit, to write the test before the functionality. At first, it's not easy, but it's still easy to begin with. It's also not easy to come up with the right test cases and what the test strategy and all of this is a big topic. So therefore you should approach it with strategy in mind, and always remind yourself that you should test what matters. I think we talked about it with the test coverage. What does it actually mean to have 100%? Is that enough? Do we need to have 200, 500%, or what does it actually mean? You need to test what matters and have high quality test cases. This is more important than just making sure that you have some tests. And also don't forget that after all, it's teamwork. So get your subject matter experts in, brainstorm together, think about what is the most crucial part together, and then formulate your test cases from the back of these discussions, and then document it maybe also on a Confluence page or so that your product managers have the confidence too. They know that their most important features in the product are reflected by a rigid test suite. And lastly, also, when you have some CI or continuous integration pipelines, you can have these tests run by your GitHub or GitLab repository whenever you push code, and your tests are automatically run. It's really powerful. It's really cool as well. And this really harnesses some power in the overall automation, and that you can do as well. And that's it from my side.
Yeah, one example of continuous integration that that I can shed light on is the way that we do it. And so we have so every time anyone creates a PR, right, or anyone's working on some new features or something, right, every time they push their code, we force people to write unit tests, and then we force people, to pass a unit test. Up until then, people cannot merge the code, right? So this is again the best place where people working on different things. You have a main branch or a master branch, which is your production branch, right? And then people working on different branches. Make sure that their code passes all the checklists, right? It goes through a checklist, it passes everything, including the unit test, right? Before merging the code into production, because you don't want to break anything in the production, right? And again, this is where you can learn additional tools like GitHub Actions, for example, right? So you can set up a GitHub action, which would go and run things in the background, right? As you push your code, and then it checks everything again, test cases and all that stuff. And then it blocks you from merging your code, right, to production. So that's how you can do it in continuous integration part. That's one way of doing it. Yeah, if people have questions, I think we'll stick around a couple of minutes. You can unmute yourself, or you can put in the chat. But yeah, thank you, Sage, for a really insightful session. And teaching us much more than we expected, and also something new that I think we all have learned. Like especially me, I've learned something new for sure.
Yeah, but same to me, really. I'm also like anyone here in the room, like we're always learning. There's always something new. I feel that it would be anything but an insult to those who have been practicing this for years and decades to call myself an expert in that, because I'm also, I guess, like many, like maybe 90% of the people out there who turned to data science and want to use all of these fascinating techniques and methods. We're practitioners, right? And as we go ahead and do our work, we just find some things that can work better, some work not so in our favor, and I'm just as anyone else, really just practicing at all the time, because this is what we do, practitioners. Like we try to apply, and this is just the latest update from my own learnings, I would want to say. And this is why I'd be also very happy to really, with anyone who's watching, to stay in touch and to see what you guys are coming up with, and stay up to date with all of the latest stuff. It's really cool.
Okay, so I think so. If anyone has any recommendations for future master classes, also please feel free to put it in the chat, and we'll be here for a minute, and yeah, then let's wrap it up.
Yeah, I think in the future we'll do a master class on how do you use a PyTest, and maybe include in that how do you do continuous integration, how do you integrate this test in your pipelines, right? So maybe we'll do a masterclass on that, where people can actually get their hands on it and learn about these things a bit more and get involved a bit more. Yeah. But yeah, this is a good start. This is a good start. First, learning more about it, what exactly it is, and understanding the idea of a test, right? Before deep diving into hands-on and trying to integrate it in your pipeline. Yeah, and yeah, we do have the slides. So thank you very much, Sage, for sharing the slides. So people are interested in slides, please email us so we can have your email, and we can forward it to you. Yeah.
Okay, I guess we can wrap it up now. Thanks.
Yeah, sure. Yeah. Thanks once again, Sage, for your time and yeah, spending an hour with us, and giving back to the community and teaching us. Yeah, thank you.
Thank you too.